Hey everyone. So like this is the first video related to Sieve, and this is the basic. I have written down like the prerequisite for this, and so you could understand it, the complexity stuff and the mathematical stuff better. So this one is the flow function. You could search on Wikipedia about it, or you could Google it, right? So basically, what is flow function? So basically, you say, let's say they have two numbers. Let's say a is equal to 5 and b is equal to 3. So what does flow function give is when you do normal division, right? So when you divide 5 by 3, so there is you get 2 as a quotient, and you get 1 as a quotient and 2 as a remainder, right? So this this one so this one is basically your flow function. That is what computers do integer division. So integer division is same as floor function. So whenever you output whenever you in your compiler, whenever you do 5 by 3, it will always store as 1. It will never store as like this. Okay. And similarly, that 5 modulo 3 is equal to 2. So this is what flow function denote. And also, like this is seal function. Seal function is what basically does is it gives highest value greater than equal to the number. So let's say when we say 5 3, okay. So it's the same, but it's little different. Like it will also give, if it is perfectly divisible, it will give like a perfect quotient, else it will give q plus 1. Like let's say if a is divisible by b, let's say a modulo b equal to 0, it will give whatever a divided by b, else it will return a divided by b plus 1. This is basically what seal function does, but you can calculate it directly. You don't have to implement this function, right? Because I have already written the relationship between these two functions. Please note down that these two functions are very important in mathematics. In everywhere it is very important. In code forces a b problems, it is very much used, so you must know this. like uh, let's say we know that 5 by 3 is 2, as according to above definition. Now let's say I calculated according to the given formula. So it could be like 5 plus 3 minus 1 divided by 3, which is basically 7 divided by 3, and it will give 2. See, both values are equal. You could also prove it mathematically using some inequalities. I will not go into detail. Try it as homework. Okay. Now one another point is that like this you have to remember. There is no proof here, but you have to remember this. This is very important. Let's say there are like n numbers, so you could say that n by log n numbers are prime, approximately. Like when you plot the graph, like let's say this is the graph, and this is the n by log n graph, so it will be like a very close graph, you could say. So it is approximate. You can use this for calculating complexity for some questions. Okay. So this you have to remember. This is very important, and it will also I will also use it to prove why complexity of C is to be n log of log. Okay. So this is the stuff. So like what I told is, like I told flow function, I told seal function, I told relationship between them. Many of you might know this already. This is basic stuff, but no worries. This is relationship between them. Many like this is not so common, but okay. Cool. So now we jump to the harmonic sum. Why we are discussing harmonic sum? Like this is important in terms of like some some complexities, like proving the complexity. Like let's say we know that like if you study in like your 12th grade, like there is like integration of 1 by x is like ln x. So same applies here, because like it is summation, and basically summation is less than integration, right? So we approximate like this sum to be log, right? Log of n. So this here, from here we approximate this is not like exact bound, but this is rough bound, and in programming we generally work on like rough bounds. There is no like perfect bounds of anything. Okay, so now let's say this is the function. We know that like 1 plus 1 by 2 plus 1 by 3 up to 1 by n is like log. But now let's say I tell you like n by 2, this is flow function. It doesn't matter, it will be like same asymptotics, like same complexity. Let's say this is n by 1, it doesn't matter. Okay, so what will be the complexity of this? It will be like let's say it will be like around n log n, right? You could see the basic common stuff, right? We are just multiplying n here, and we are assuming its complexity to be n log n, right? So this is, now you know this, right? So remember this. I will ask one question on it, like let's say uh, this for function, like how much, what complexity of this for function is running, right? So this for function will be running like n by a times. You could see that, like why is that? Because we are jumping like a jumps plus a always, so it will be like n by a like not approx, it's perfect. Okay, so it will be jump like total n by a times. So now we know this, right? We know that this complexity is like n by a. So can you calculate the complexity of this nested for loop? So you could say that like for I is equal to 1 to n, let's say one sec. Okay, now this is n log n, you know that, you got, right? Like this is summation is what, like this is basic sum, and this is integration. No need to remember this, I am just doing this, like no worry to remember this. Summation is less than, no need to remember this, but it is just for knowledge purpose. Okay, this is not important. Just remember that this function is n log n, this is important. Also this is important, like why this is log n, this you should know just, right? There is this important. Okay, and now you know this, like this runs n by a times. So we will try to prove complexity of this one block. Like let's represent this block to name to be 1. So this block complexity, what will be this block complexity? So let's try to analyze it. Like let's say when I is equal to 1, it runs like n by 1 times, right? When let's say I is equal to 2, it runs like n by 2 times. and it's up to why is this n by 2, like you can see from here, like from 2 you can see that it's n by 2. So like similarly for I is equal to 3, I is equal to 4, and when you sum up all this, it comes to be like n by 1 plus n by 2 plus n by 3 plus n by 4 up to n by n. Now it is same, right? This and this are same, so this complexity will be like n log n, right? See, these are like two nested loops. Like generally by seeing this it looks like n square, but its complexity is n log n. So this is very important. We will use this in proving Sieve complexity, like why this and these are like mixture of two gives complexity of Sieve, but let's say that way I will explain later. But just remember this, like what I explained until now. So this complexity is n log n, you got right? Why is this n log n? Okay, so now a question for you guys, like I proved it this like this, so we came to complexity to be n log n, right? Now I am asking you guys, like what will be the complexity of this? There are 3 nested for loops, right? So what will be the complexity of this? So basically now we could do the same analysis, but let's say pause the video and think around it, like what will be this complexity. Okay, so I will start explaining like why, how we will calculate the complexity. So let's first thing is like fix the stuff, like in programming basically whatever we calculate, let's fix something and try to calculate the dependent stuff on it. Like let's say I fixed I is equal to 1, so what will be the complexity? So when you fix I is equal to 1, it will be same thing as this for loop. It will be its complexity will be n log n. Now let's say I do for I is equal to 2. So what I is equal to 2 is doing is like it's just reducing to n by 2, and you could analyze it like it's giving the same complexity as n log of n by 2. Similarly for n by 3, I is equal to 3, it's n by 3 log n by 3 up to n by n log n by n, right? So now you try to calculate the complexity from it, like what will be the complexity. So just approximating, like let's say we don't know about, like let's say it doesn't matter like whatever is the denominator, we are just assuming like some bound. Okay, just remove this bound, it will still be like greater, like right, from this. So it will be like summation n by I log n. Basically just this is less than, this is less than one sec, I is equal to 1 to n. Okay, so this equation is still less than this. Okay, so when we it is greater, sorry, it is greater than this. Okay, so whatever we calculate is bound, it this bound up this above equation bound will still be less than equal to this bound. Okay, so we will we'll just calculate this bound. This is what we do in programming, right? We just calculate approximately every stuff. So take the log common, and if you take the log common, it will remain same as the n by I stuff, which I explained later, which I explained previously, sorry. So it now you know that like is n by I, so its complexity is n log n. Same from here, same from here, right? So total complexity will be log n into this one. So complexity is n log n of log n, right? Now like let's say what we learned. I will revise the stuff for you, like what we learned about flow function, seal function, like we calculated the relationship, I calculated the prime density, I explained the harmonic sum to you, and okay, what is this? Okay, so this is the harmonic sum, and this is the two nested for loops. Remember that what is different in here, this is like j plus equal to I, and here it's j plus equal to I, and here is k plus equal to j. This is different, right? So it is not like nested for loops, and its complexity will be, this complexity is n log n and this complexity is n log square. Okay, you could try adding one for loop again, and you could analyze the same complexity. It will be less than n log q, and but doesn't matter. Okay, it's not that important, but just I am doing this for like mathematical complexities, like how we prove that this is n log n and this is n by a. Okay, okay, one thing I forgot to tell you, like let's say there is like question, like you have to find one question is there, like let's say I give you two number, right? Let's say 11 and let's say 3. Okay, so I told you like find the number which is smallest number and greater than this, let's say this is a and this is b. Okay, so I told you like find smallest number which is greater than equal to a and divisible by b. Okay, so what will you guys do? Like you will not start like looping from 11 to 11 12 13 and start checking like it's divisible by 3 or not, right? So I told you about the seal function, right? So you could apply the same thing here. You could calculate the seal value, you could calculate the a by b and multiply it by b, you will get the same value. So let's say what will be the seal value, it will be like a plus b minus 1 upon b into b. Okay, so it is around like 14 minus 1 13 divided by 3. Okay, 13 divided by 3 into 3, which is 4 into 3, which is 12. So 12 is the correct answer. So why I solved this example is because I will explain segmented sieve later. So in segmented sieve, like this is used for like jumping part, but okay, remember this example, this is like it will be also used like in some code forces contest like a b. This is like basic stuff, so it's like very not important but useful to remember. Okay, cool. So okay, you could take the notes if you want of this. Okay, cool. So that's it for this video. Okay.